Hey guys, what is happening? Today we are going to be dealing with sequences and series. Probably just sequences to get started with, okay? And there's a lot going on. I might miss something, who knows? But if I do, just be forgiving. We're going to be working on this for a little bit. This won't be the only video. First thing you might want to know is that a sequence is something like 2, 4, 6, 8. That's a sequence of numbers, okay? You might also have an infinite sequence. That would be 2, 4, 6, 8, dot, 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 and it just goes on forever. Okay, so let's kind of explore with writing terms of a sequence. All right, so here we go. Part A. Write terms of a sequence. Okay, and let's do two examples. Write the first 6 terms of a sub n equals 3n plus 4, okay? So that is a sub n. That's a little tiny n. It's kind of like base n, but you're not going to call it base n. It's not a base n. It's a sub n, okay? And I'll show you what that means, okay? There's different ways you could write this. I'll do an example of each. But this one right here, this just tells you what term you're talking about. So watch this. If I do a sub 1, okay, well that's the first term, and it equals 3 times 1 plus 4. So 3 times 1 plus 4, okay, and that's 3 plus 4 is 7. So a sub 1, in other words, the first term is 7, okay? All right, so that's, write the first 6 terms here. I'll do one more. A sub 2 equals 3 times, you guessed it, 2 plus 4, okay? And that's going to be 6 plus 4 is 10, okay? So that's how those work, okay? And it says write the first 6 terms. Let's just do 2, okay? All right, just to save time. Here's another example. All right, let's do dot, dot, dot of, how about this? F of n, okay, equals, in parentheses, negative 2 to the n minus 1. Okay, so now let's just write the first 6 terms, or the first couple terms of this function, where f of n equals negative 2 to the power of n minus 1, okay? And so you can write f of 1, right? That would be the first term. Or you can write a sub 1. However you want to write it, that's cool. They're both basically the same thing, okay? And that's going to equal negative 2, right? And n is 1, so 1 minus 1. That's negative 2 to the power of 0, which equals 1. So there's our first term, okay? F of 2, or a sub 2, it doesn't matter, equals, you're going to have negative 2. Just follow the rule. Now we're plugging in 2 minus 1. So it's 2 minus 1, which equals negative 2. 2 minus 1 is 1. And negative 2 to the first power is just negative 2. Okay? And then you just go along like that. All right, so now here's where it gets interesting. I'm going to give you a pattern. I'm going to give you a sequence. And we're going to see if we can't figure out the rule. Now, it's kind of a mean thing for me to do because I'm going to give you some funky sequences, and so is your book, okay? And we're just going to see if we can't figure it out, okay? Really quick. That's the bummer part, okay? It really is better if we had time, okay? But anyway, whatever. The next lesson and the lesson after that, I'll show you quick ways how to do this, okay? But for right now, let's write rules for sequences, okay? Write rules for sequences. All right, and I'll give you an easy one to start off with, okay? So the first thing we're going to do is find the pattern. So watch this. Here's an easy one to start off with. We have negative 1, negative 8, negative 27, and negative 64, okay? Now hopefully you guys recognize that these are all powers. They're all perfect cubes, okay? So, isn't this guy right here, isn't that negative 1 cubed? Okay, isn't negative 1 cubed negative 1? Isn't this guy right here negative 2 cubed? Negative 2 times negative 2 times negative 2, that gives you negative 8. Isn't this guy right here negative 3 cubed. That gives you 27, negative 27. So the rule is going to be, you can say a sub n if you want, a sub n equals, okay, negative, okay, n raised to the power of 3, okay? Because if you plug in 1, like we did here, that gives you negative 1. If you plug in 2, like we did here, that gives you negative 8, and so on. Okay, so there's my rule. All right, so let me throw this one at you guys. See if you could figure this out. We have 0, 2, 6, 12. All right. So I'd love to let you guys play around with this a little bit, and if you're just watching this on your own and you're not in class, pause it. See if you can't figure it out. Okay, but let me show you how tricky some of these get, okay? Here's what I like to do first. If I do this, what I like to do every time, if I'm just trying to figure this out, is write 1, 2, 3, 4 on top of it. That way I know that that's my first term, my second term, third, and fourth term. But also, one cool thing you might notice is that if you look at some of these, you might see some patterns. For instance, what's 3 times 4? That's 12, right? What's 2 times 3? That's 6. What's 1 times 2? That's 2. So there's definitely something going on connecting it, okay? There's a lot of ways you can do this, okay? Let me show you one way that I see. If I take 1 and I square it, right? I get 1. And if I subtract 1, don't I get 0? See if I could do the same thing for the next one. I'm trying to get a 2, right? Let's try taking 2 squared. I get 4. Subtract 2. Don't I get 2? Let's see if that pattern holds. I get 3 squared minus 3. That's 9 minus 3 is 6. 4 squared minus 4. That's 16 minus 4 is 12. I think I found the pattern, okay? So basically what we have is we have n squared minus n, okay? Which can be factored into this. N times n minus 1, which basically is kind of like what we were doing before, right? Okay, and so now we know that a sub n, okay, a sub n is going to equal n times n minus 1. Okay, here I'll show you another one. Let's do another one. See, make sure I'm lined up right. Okay. All right, so how about I have something like this: 3, 8, 15, 24. Okay. Again, I like to put 1, 2, 3, 4 at the top. Okay. All right, and if you notice, I notice 15, okay? For some reason I saw a 3 above the 15 and I said, oh, 3 times 5, that's 15. Well, what did I do? I went 3 times 2 numbers higher, right? Well, let's see if that works here. 4 times 2 numbers higher, 4 times 6, that's 24. Ooh, look, 2 times 2 numbers higher is 4. 2 times 4 is 8. 1 times 2 numbers higher is 3. So 1 times 3 is 3. Hey, we found it, okay? So watch this. Look what I noticed. I went 1 times 3, okay? 2 times 4, 3 times 5, 4 times 6. Okay, and look, I have a 1 in there, I have a 2 in there, a 3 in there, and a 4 in there. That's what you always want. Whatever you can do to get that 1 in there and that 2 in there, you're good. So now I know that this is going to be n times, this is n plus 2, right? This is n times n plus 2. So there's my rule. I'm basically done. So a sub n is n times n plus 2. All right. So have fun with those. Don't get too frustrated. They are kind of crazy sometimes, okay? All right, let me give you, let's change directions a little bit. Let's go on to a series, okay? So here's series, okay? And basically a series is the same thing. Instead of it being 2 comma 4 comma 6, it's going to be 2 plus 4 plus 6 plus 8 plus dot dot dot, okay? All right, and here we go, part C, summation notation. All right, and what we have here is sigma. That's the Greek letter sigma, okay? And we're going to use it like this. We have I equals 1, okay? And this is where we start. And hopefully this will all start to make sense later. And let's go up to 5. Okay, and this is where we stop. If you're just like frantically copying stuff down, don't worry about it, it's fine. And then the rule that we're going to use is 2i. Sometimes you'll see an n, sometimes you'll see an I, okay? But basically what this says here is we have a rule. This is my rule. Here, I'll go ahead and write that. That's my rule. And basically what this equals is 2i, but instead of 2i, we're going to replace it with 1, okay? So the I is 1, okay? And that's where we start. And we're going to go all the way up to 5 using summation notation. It means we're going to go from the numbers 1 through 5 and add up all those numbers. So the next one, watch, we're going to add 2 times what's after 1, 2, plus, follow the rule, 2 times what's after 2, 3, plus 2 times 4, plus 2 times 5, okay? And we stop at 5 because it tells us to stop at 5, okay? And now we just have 2 plus 4 plus 6 plus 8 plus 10. Okay, and watch this. 12 plus 12 is 24 plus 6 is 30. So this equals 30. I do that, I go on the ends. 12, 12, half of 12. Ooh, interesting. That might be something worth noting. Okay, let's do another one. Let's try this. Sorry, this is so rushed, but it kind of has to be. So we have sigma. We have I equals 1 up to 10, okay? And the rule is 2i minus 1, okay? And let's see what we have. We have 2 times 1 minus 1, okay? Plus 2 times 2 minus 1, plus all the way up to, watch this, all the way up to 2 times 10 minus 1, okay? All those guys added together. I didn't write them all down because I don't think you'll need to. Watch this. 2 times 1 minus 1, right? 2 times 1 minus 1, that's 2 minus 1 is 1, okay? Plus 2 times 2 is 4 minus 1 is 3, okay? Plus, let's plug in 2 times 3. That's 6 minus 1 is 5. Do you see what's happening? It's going up by 2's. So 1 plus 3 plus 5 plus 7 plus 9 plus 11 plus 13 plus, how many am I supposed to get? 1 through 10 is 10 terms. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 terms. And now watch this. This is great. 20 plus 20 plus 20 plus 20 plus 20. That's 25 times. Guess what that is? It's 100. Isn't that great? All right. So now I have only a couple minutes. I'm going to write down some formulas for you. Okay. Here's a couple formulas. Part D. Formulas for sigma. And if I get cut off, just find them in the book. Okay. So here we go. Here's one of them. All right. I through 1 all the way to n of 1 equals n. Okay. Here's another one. And I'm not, unfortunately, going to have any time to practice these. Maybe I will, but I need to stop talking. I equals 1 all the way to n of I. Okay, and that's going to equal n times n plus 1 over 2. And here's another formula. All right, I equals 1 all the way to n of I squared, and that's going to equal, oh boy, this is a fun one, n times n plus 1 times 2n plus 1 all over 6. All right, and I might have time. Let's go really fast. Ready? Example, see if I could beat it. All right, I equals 1 all the way to 5 of I squared. Okay, here we go. Let's see what that's going to equal. It tells us to follow this, okay, whatever n is. So we're going to have 5, okay, times 5 plus 1 times 2 times 5 plus 1, okay, all over 6, which is 5 times 6 times 10 plus 1, that's 11, so times 11, all over 6. These cancel, 55, just in time. Love you guys, peace.